with confidence intervals in chapter 6. No, these aren't going to get any easier. So, and we're going to go a little bit quicker. Confidence intervals. The first section dealing with the mean of large samples. Second section, mean of small samples. Third section, confidence intervals for proportions. Remember, a proportion, we talked about this earlier this year. A proportion is just a percentage. All right, so writing it as a fraction, which is just like a percentage, just like probability. Same idea. And then 6-4 confidence intervals for variance and standard deviation. I got on here, it's not part of the syllabus, that's probably because I copied off somebody else. We'll probably hit on that. Nothing really difficult about it. So 6-1, dealing with the mean confidence intervals for large samples. And if I was doing this, I'd just write confidence intervals, that'd be my title. What we're going to do, find the point of estimate. This is very important. You're finding a point of estimate. Got to understand what that tells you. Otherwise, you won't understand this whole chapter. And then we're going to find the margin of error. Somebody asked me what E was a little while ago. Guess what it is?
The margin of error.
Margin of error. It was on that other vocab because I got to it. I forgot to change it because last year I got to it earlier. Got to this chapter earlier, so it was on there, and we hadn't gotten to it yet.
My dad is yet to go to work.
Really? Yeah, depression.
Yep. He has never missed a day of work in like my lifetime. He's missed like 2 days.
Why? Sick?
Because they lost the
The
Super
Bengals
Bowl.
lost. He just gets up and watches Sports Center.
I'm confused.
See, that's,
His dad didn't go
I don't
work
know
'cause
why
the
he would do
Bengals
that.
lost.
I know, it just makes him even
Yeah,
sad.
makes
Because
him
they talk
sad.
about stuff like, and he's like, he just sits there.
Anyways,
How
what
Cooper
percentage
Cup
you told her?
absolutely obliterated the secondary.
That's all they talk about is, oh, look how great Aaron Donald is. And I'm like,
He was literally offsides that last play.
Yeah, he was.
There's a picture of
I wore,
it.
so we at work, I had to work on Sunday, and I had to wear, I didn't have to wear, they said we could wear like Bengal shirts or whatever, and I wore a Bengal shirt, and I was looking in the window, and this little kid was like, Mom, she's wearing a Bengal shirt, and like freaking out, and he looks at me and he's like, the Bengals shirt. And I was like, okay, buddy. I was like so scared.
And that last play, we got pass interference. The whole offensive line jumped. So the play should have been dead. They literally showed it. Literally, the announcer says, like, oh, they jumped and they didn't call the flag.
Well, you should have known karma was coming because that one touchdown for the Bengals should
T.
be
Higgins?
That was a total face mask.
No, that was
He was,
Jamar Chase. He ripped Jalen Ramsey's
No, that's T.
face.
Higgins.
that one should have totally been flagged.
Oh, T.
yeah.
Higgins.
Which I don't ever complain about officiating because it all evens out.
But they didn't call a single flag till the last 2 minutes.
That's,
Yeah.
That was different. There was like 3 penalties, and then there was like 5 in the last 2 minutes.
Yeah.
Why? Hang on.
But the one that I had, and I'm not complaining about it, the one I had a question about was, what was the personal foul
Hitting the guy at the end zone.
in the end zone? Because they called it a dead ball foul, and I'm like,
The play was still live. He hit him trying to knock the ball out.
Yeah, they get an automatic
Yeah,
first
they
down.
were super
yeah,
risky.
they got the play over because they
They had a
jumped.
foul too.
Oh, okay.
They jumped, and if they would have just explained that, because I'm thinking, it can't be a dead ball
Because the play
foul.
was still live.
If you call it a personal foul, that's fine. If you call it, which I don't think it was.
It wasn't even that dirty of a hit.
Right.
He's trying to knock the ball out.
But if you're calling it a personal foul for targeting or whatever, that's fine, but you can't say it's a dead ball now. I didn't understand that, so if they would've come back and said, oh no, it wasn't supposed to be a dead ball.
He could still be a flag, but
Right. But that would've scooted them back, and then I think that, that could've made a difference.
That
But
little-
they couldn't have thrown
No,
an
but
out
look,
route to Cooper Cup in the end zone with Eli Apple on him, which makes no sense to me.
The Logan
They were
Wilson.
finding out what
my son threw a fit the whole time. Why they got Apple on him, babe? he was only about 3/4 of the game, so, I mean, it wasn't like Cup was just tearing him up or anything. There were several times he was doing his job.
If
He
I
could
was
get
the
beat sometimes.
Bengals though, I would have put like Jesse Bates or Von Bell as the safety, doubling him.
Over top of him.
Yep.
And some of them, I'm sure some of them, they did have it set up that way, I think.
Because if I was defensive corner, I know they're going to Cooper Cup.
Did he tear it?
He tore his ACL.
He tore his ACL?
Yeah.
That's what I figured.
Which sucks. I hate Aaron Donald.
He didn't tear it, but has he tore it before?
Yeah.
That's what I thought.
That's, the one smart thing I have heard on any of the stuff I've listened to is if you wanna be mad at somebody, be mad at Zach Taylor, because
Running.
when the Rams changed up their defense in the second half to get Donald free, the Bengals didn't do anything about it. They didn't adjust.
Because Aaron Donald didn't do a single thing in the first half. We doubled him every time.
Except for get mad because,
We,
and he should have had a couple of personal fouls.
Yeah, we're hitting Joe Burrow like that.
Because he got mad when he knocked Burrow out of bounds. It's one thing to push him out of bounds. It's another thing to just
rocking.
Because, like, first off, Joe Burrow's going out of bounds. Like, if he's going this direction, Joe Burrow's not quick enough to cut right back up. No
That's
one's.
another thing, in the NFL today, you're not supposed to hit a quarterback at all. At all.
And normally during the regular season, that would have been a flag.
Yep. They're going to call it in Super Bowls.
But there, I don't know. All right,
We'll be back.
find the point of estimate and the margin of error. That's the main things that we're going to do today. Construct and interpret a confidence interval. What a confidence interval is we're going to look at something and we're going to decide on a number line and say, I don't know, this maybe 2 and 50. Who knows what the numbers are? It doesn't matter. But we're going to put the mean right here in the middle, and we're going to say that we're confident that the mean is going to fall in that range a certain percentage of the time. So that's what we're doing with this. Determine the minimum sample size. We want the very smallest that we could actually do and get numbers that still make sense. So you can't just pick a sample and pick 5 people and say, oh, well, look, all 5 said that they like this product, and then say the product's the greatest thing ever. All right, you gotta have a minimum sample size so that you can make actual good representation of what's going on. Statistical inferences. Remember, an inference is just us making some kind of statement about something. We can only make these inferences when one of 2 things happens. One, our sample size is greater than or equal to 30, or the sample size is normally distributed, and we know the standard deviation of the population. This isn't going to happen very often. If we know the standard deviation of the population, that means we probably know the mean of the population also, and we know all the information about the population. So we're probably not making inferences about it because we already know exactly what's going to happen. So it's normally the first one, n's greater than or equal to 30. If our sample size is larger than 30 or equal to 30. So that's what you got to look for to make it so that we know that all this stuff will work.
So we have hope for the Reds though, because the last time the Bengals lost the Super Bowl, the Reds won the World Series. And they weren't supposed to be good either, so maybe.
You guys just have a problem with the NFC West.
What?
Yeah, you can't beat the 49ers, you can't beat the Rams.
You get there.
Got to score more. That's
Our offense went dead the second half, and our defense played awesome. If we would have scored at all, we'd win that game.
Your offense went dead because, I guess, like he said, they didn't make an adjustment.
Our defense played awesome.
T. Higgins has the best hands in the NFL. mean hands, I mean
Just pitching.
like just hands.
Point of estimate for a population, point of estimate. Point of estimate is a single value estimate for a population parameter. A parameter is like the mean, the median, the mode, all those different things. The one that we're gonna deal with the most is the mean, and I think that says it here. Most unbiased point of estimate is the mean. And what we're gonna use, because we're not gonna know the whole population, is we're gonna use the mean of the samples, or X bar. So that's the one that we're dealing with, that we're gonna be dealing with most of the time in here. Remember, mean is for population, or mu is for population, X bar is for a sample.
If you sign up for Brown, might be. We're just going for secondary. We're just going for a secondary.
Isaac, remember at meetups when our waitress said something about the Simpsons?
Yeah, they come true.
And it come true, yeah.
That was good. Once
We just missed the peak of Cincinnati sports. Like, you grew up when the Reds were freaking awesome. Like, when you were a kid, they won the World Series every other year. Like, we went good.
No, I can't even stand to go to a Reds game
I
sometimes.
love
It's-
going to Reds games.
One time I was at a Reds game, and I was like 8, and we were right behind the dugout. And I remember I brought my glove, and I went to, the catcher brought a ball in, went to throw it to me.
You
And
dropped
some
it.
old man snagged it right behind me. I think my dad almost beat him up. And I started crying, but then I got it back. But how
That is
how are you
mean.
stupid? How are you got stupid? I mean, he's standing there. He's
He
going-
saw you?
Yeah, the dude, whatever the, I don't know, I can't remember who it was. Catcher's
Are we
like,
gonna
"Here
need
you
our
go."
Are we gonna need our calculators today?
He runs back to his seat.
I want to.
I gotta
How'd you
Can I
get
go
one?
check the locker room?
My dad went and got it from me. I thought my dad was gonna beat him up.
The validity of the estimates.
It's traumatizing.
The validity of the estimate is increased if the sample statistic is unbiased. We'll talk a little about that. The main thing is, the bigger the N is, the better your estimate's gonna be. So if we can do 100,000 as our sample, then that's gonna make the estimate better. If we only do 30, then the estimate's not as good. So sample statistic needs to be unbiased, and our sample size needs to be as big as possible. That just makes everything that we do more valid.
Push a beat.
I'm just kind of sad that we didn't make it because Junior upload since he put 2 picks at the end of the game within 2 minutes. We had a 17. We had a 10-point lead in the fourth quarter. You guys had like a 4-point lead. Once T. Higgins caught the touchdown and Stafford threw that pick, I thought it was over. Not even that. You guys had to score a touchdown after that.
Why was he have no one?
You were guys would have scored a touchdown.
Yeah, I would not pay that much.
I just want you to do it next year so that I make no fear.
And they're gonna kill them.
Just
Lane
breaks
actually
their
mic'd
kicker
up on
record.
some of that game.
No, it's oh.
Need it back.
No, I got it.
Finding the point of estimate. To find the point of estimate, what we're going to do is social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample of friends for 40 different users. Find the point of estimate of the population mean. So we don't know the whole population. These are how many friends each one of these users have. So you probably look here, and this is Ebersole probably there. And won't say names who this is, but that's somebody who you're probably sitting close to right at the moment.
Me.
Not too many friends. No, I'm just kidding.
Me.
But this is the way it's set up.
That is true. There is a whole town page.
Actually, that is Michael Brown.
All we do to find the point of estimate of the mean is we add up all these numbers and we divide by how many of them there are. So we're just finding X bar. And that's going to be our point of estimate. This point of estimate, we're estimating about what the mean of the population is going to be from our sample. Nothing really hard about it. I added them all up. Somebody help me out with the calculator. I added them all up and I got 5,232 and there was 40 of them. Divide that and what do we come
Yeah,
up
was
with?
that like a test score? What was that?
Something about 30. You said 40?
Yeah.
130.
130.8.
Not very good.
So our X bar, our point of estimate, that's the number that we're dealing with, is about 130.8 friends.
So the average person has that many friends.
Right. So we're saying, we don't know what the mean is, what the actual mean of the population, but we're given a point of estimate of this. Now, it is very, very unlikely that the mean of the entire population is going to be exactly that. That's very unlikely. All right?
That's why it's an estimate.
But we're going to give an estimate, and then we're also going to make an interval and say, okay, we expect that things should fall within this range. Market researchers use the number of sentences per advertisement as a measure of readability for magazine advertisements. In other words, if you make an advertisement have too many sentences in it, nobody's going to read it and they're just going to skip over it. The following represents a random sample of number of sentences found in 50 different advertisements. Find a point of estimate of the population mean. So same idea, we'd add all these up, divide by how many of them there are. When I did that, there was 600, and it added up to 620, and there was 50 of them, and it came up to about 12.4 sentences.
I wouldn't even read 12.
Yeah, I probably wouldn't either. But. So your point of estimate is about 12.4 sentences. That's about the average for our sample, and we're sort of guessing that that's about what the average for the population would be. So if we do an interval for this estimate, we put 12.4 like right in the middle on the number line, and then we want a range of values to estimate that from. And what we're going to end up doing is something like this, and we're going to use a graph like this to do it. We're going to use our calculators to come up with it, but we need to know how far out this way are we going to go and how far out that way are we going to go, and that's what we're going to learn next. So interval estimates, an interval or range of values used to estimate the population parameter. And with this, you got to be careful because we're not saying actually that the mean of the population is going to fall in there, but there's going to be a certain percentage, and we're going to say that we expect that 90% of the time the mean would fall in that range.
Are those the notes?
Yeah.
So, oh, 2 to 15. Like grade, yeah.
So to look at this, to form an interval estimate, first thing you need is your point of estimate. That's, for now, that's going to be our X bar. We need to find that. And then we need the margin of error. We need those two things. And that's the next thing we're going to learn, how to find the margin of error here in a second. To make this on a number line, what you're gonna do is on your number line, you're gonna put the mean somewhere in the middle, so 130.8 maybe. And you might not even put 130.8, you might put 130. And then maybe make this 140, 150, and we probably should go 135. 135, 140, 145, maybe go by fives, 125, 120, 115, and 130.8 is going to fall somewhere like right in here. And we would mark it and maybe write 130.8 right there where we marked it. And then our margin of error, what we do with the margin of error is we add to get the high limit, subtract to get the low limit. So we take 130.8, somebody help me out, what's 130.8 minus 15.7?
115.1.
So that'd be somewhere like right here, and we put a parenthesis right there. And I think you did some of this in pre-calc where you put parentheses on the number line and stuff to show where things start and end. And
It's a good possibility, but I probably just wasn't listening.
what's 130.8
Me too. I didn't take.
plus 15.7?
What is it? Sorry.
130.8 plus 15.7.
146.5.
That's going to be out here somewhere, and we put our other parenthesis here. This is our interval. That's what our interval is going to look like. That's one way to write it, is using that number line. Some of you can't, I'm not supposed to use this word, but you can't be lazy doing some of this stuff. When I graded that last test and I looked at your when you have to draw the our normal curve. Some of you get awful lazy drawing a normal. It's not quite that difficult to draw this normal curve. Trying to not say anything real mean here, but I don't know how else to explain it if you can't draw that normal curve.
Push pause and say it.
No. Before finding the margin of error, we must decide how confident we want to be. Again, I wouldn't write this down. That's just telling you something. I would write this down. The level of confidence. Level of confidence is C. That's what we use to represent it. And it's the probability that the population parameter is in the interval. Notice it says the population parameter. So we look at that interval that we just made, and we want the probability that that parameter is going to fall in that range, in that interval. We usually use, and most of the time in here, these are the three that we're going to use. We want to be either 90% confident, 95% confident, or 99% confident. Those are a level of confidence. Please make sure that you still have these charts. There's a little chart on the very front page, and it says level of confidence C. We're going to use that little chart so that we don't have to do something on our calculator, or we don't have to figure it out over and over and over again. They tell you the numbers that you're going to use. The other ways that we could, or the other numbers that we could use, if they throw in something like, maybe they throw in an 80% or a 70% or a 50% confidence level. Then we use the standard normal chart here and on the back page, the back of the front page. But most all of them, about 99% of them is going to use one of these three. So this is the chart, it's right there on your paper, I wouldn't write it down again, I mean, you can if you want, but that's up to you. It's right here on the front page of this. And it just tells you, for 90%, the Z-score is 1.645, that's the number we're gonna use for 90%. 95%, it's 1.96, 99%, it's 2.575. Those are called your critical values. Again, the level of confidence is the area under the standard normal curve between negative ZC, whatever that critical value is, and positive ZC. So we're looking at this, and all this is saying, if we look at 90%, we want 90% between two numbers. So we're saying 90% of the data falls in this range. What percent of the data falls over here? Think about it for a second.
5%.
5%. What percent falls over here?
5%.
All right? That's if we're at 90%. So we're looking for this Z-score and this Z-score. And that Z-score that goes there, this one would be negative 1.645. This one would be positive 1.645. And we could do the same thing with the other two. If we did the 99%, we want 99% chance that it falls in that range. A little harder this time. What percent is over here? 0.5%. What percent's over here? 0.5%. So 0.5% on each end. Which one of these is it more likely that our mu is going to fall in? Now the bad thing with that, it's more likely that it's going to fall in there because it's wider. So if we said we want to be 100% confident, then we just make up some stupid range. And we say we're sure that the mu, let's say I ask a question like, what's the IQ of all the Providence Stats students in our classroom? And I say, I want to be 100% confident
It's between 0 and 50.
that it falls in this range. And I throw in, it's between 0 and 7,000. Am I 100% confident that it's going to fall in that range?
Yeah.
Yeah.
Take it or leave it.
She was an absolute genius.
I'd be the
The guy that
7,000.
literally like he's 100% of his brain.
You would?
So you guys are worried. I gotta shut up. Critical values are the values that separate. That's what we were just talking about. So we're saying it's improbable that it's going to fall out here, outside of our critical values, and it's more probable that it's going to fall in here. That's what we were just saying, so nothing really there that's all that real important. Those are just our critical values, those two Z-scores. Level of confidence C is the probability interval estimate contains the population parameter. We already said that. This is what I was just going over. Those are your critical values. To find them, or to find the area remaining in the tails out here, we just did that. You just take 1 minus whatever that confidence level is. You guys were doing that a second ago. Take half of it on one side, half of it on the other side. If the level of confidence is 90%, what this is telling you, and you've got to be able to explain this stuff. It's not going to do any good to be able to do all the math and never ever be able to explain any of it. If the confidence level is 90%, what that's telling you is that you're 90% confident that the interval contains the population mean. So we're 90% confident that whatever interval we made up contains the mean of the entire population. uh, 99%, we talked about that. Sampling error. difference between the point of estimate and the actual population parameter. So in other words, the difference between your X bar and your mu is called your sampling error. We're not going to deal with sampling error a whole lot because if we're finding samples, do we usually know the mean of the population? If we know the mean of the population, there's no sense going through and doing samples. If I know that the average weight of all National Trail students is 125 pounds, there's no reason to go through and find any samples because we know what the average is of the entire population. Must be another one. So if we don't know mean of the population, for every sample, the X bar is going to change. It's going to be a little different for each sample. Hopefully you know that by now. Main thing here is to know that this right here, that's the main idea of all this. Sampling error is X bar minus mu. That's a mu. Starting to get lazy, not make my mu's very well. Now,
I don't know how you make the mu. I just put an M. It's just weird.
that's like a perfect one.
I just put a 10 too.
Just make sure you know that what it is.
My standard deviation with mine always looked like a 6.
What?
Mine always looked like a 6. Like I'll like.
Draw it backwards.
Do you have it
Maybe yeah.
Again, mu is generally going to be unknown. Again, if it's not, then I'm not sure why we're doing all the stuff that we're doing. Margin of error. This is important. This is where we're starting stuff at. The greater possible distance between the point of estimate and the value of the parameter. It is estimating for a given level of confidence, which is our C. So main thing here, I don't know that I'd write all this down. I just write margin of error and then this stuff. E stands for margin of error. Now we can take that test again and
Man.
you'll know what it is. E stands for margin of error, and this formula right here, this formula, we're not going to use it very often. That's the main formula. That's the one that we're going to use.
So we should just write E.
E equals that one probably.
If we don't write any
I
other.
need a new notebook in my room.
So is Z the, like,
Z is that critical value that we just got talking about that was on that little chart.
so like 90 is like 1.2, okay.
Little chart, yep. This is our sigma, this is our standard deviation. The other thing I would write down, most of the time we're not gonna know that standard deviation, that's the standard deviation for the population. Most of the time we're gonna use S in the place of that.
Wait.
This is called,
Cody's back.
Where's the goods?
I'm gonna look up character with white
this
shirt
is also
and pants.
sometimes called the maximum error or the, of estimate or the error of tolerance. But I'll call it the margin of error 99% of the time, so if you see it written some other way in the book, might be one of those two. So the magazine advertisement data that we did, we want to do a 95% confidence level. So have out your paper there so you can tell me what the ZC is for that here in a second.
Is it the little chart?
Yep, assume that The standard deviation, the S, is 5.0. So what we're going to do here is we're going to take that formula that we just had, which was Z sub C times S over the square root of N.
So our S is 5 point.
I think it wasn't N on this one. I can't remember what N was. I think it was 50.
Yeah.
Was the magazine one?
Yeah, it was
They did 50 sample or 50 in the sample. So the Z sub C is what you get from the little chart. If we're at 95%, what's Z sub C?
1.96.
1.96 times our S, which is 5.0, divided by the square root of, square root of 50.
We can't leave it just 5.
Yeah, you could leave the top number just 5. Now, when I'm doing this on my calculator, I usually do this part first. I put in 5 divided by the square root of 50 hit equals. Then just hit times 1.96. And that's going to give you your E.
1.3859.
So 1.39, is that pretty close?
Yes.
I'd go out a couple of places probably, that's probably enough. That's our margin of error. And this is just showing you 1.96, we just said that, right? So, whatever. We should have looked at this, and I forget to do this all the time. Was our N bigger than 30? It was 50, so I just skip over because I don't even think about it. Like, all right, it's 50, and then I go on. But you gotta make sure that it's bigger than that.
Oh my gosh.
They rounded off to 1.4. I wouldn't round it off that far. That's too far to round it off.
Okay.
1.39.
So if our N isn't,
Oh my god.
Then we can't do any of this
30?
stuff.
But if it isn't bigger than 30, would they give us the standard deviation?
They might give you this, and then they'll say, oh, so you can do it. And again, if they give you that, then that problem, if you know the standard deviation of the population, then you probably know the mean of the population, and I'm not sure why we're doing all this.
So most of the time, your N's probably gonna be
Right. Now, next section, this section deals with large samples. And when I say large samples, bigger than 30. Next section is going to show us how to deal with small samples. Now, once we have that, once we know that our margin of error, and I'm going to skip over this because I want to get through this a little bit. Because this is doing the same thing.
Wow.
Once we have that, this is the next formula. And this is one of the more important things for today also, if I got anything else. Give you a second, make sure you write that down carefully.
You know the nose. What do you think we've been doing for the last?
Cody, did they get you taken care of?
Yep.
Game and sit stage or floor.
I need to talk to this place out. I was supposed to tell her to give me a. Why is it closed?
You.
A lot. That's not a lot.
So what this says, X bar minus E.
Oh shoot.
That's your mean of your sample minus your margin of error. That's on the left-hand side. On the other side is X bar plus E. So that's on that side. So all we're doing with this, you're taking your mean, which was right in the middle, whatever you figured out that X bar was, you're putting it right in the middle. And on this side, we're subtracting off the margin of error to get that limit on this side. And on this side, we're adding on the margin of error. And whatever confidence level we used here, 90, 95, 99, whatever we used there, that's what we're saying. We're saying that we're 95% confident, 90% confident, 99% confident that the mean of the population is going to fall in that range or in that interval.
How would you do that?
So we're gonna, if we gotta find X bar, that's where we had the big long chart.
Yeah.
And we had to add them all up and divide by how many of them there were. That's gonna be our X bar. So we'll know those two. To find E,
Okay.
we do that right there. Remember, for segment here, we're probably gonna put in S instead because we're not gonna know the population.
So it takes a while to
Investigation.
like work really big number now, like, or would you do like?
It could, I mean, if you had a sample, that's why most our sample sizes don't, we're not gonna have a sample size of 100,000 that you have to set and go plus, 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 plus.
Lose track. Oh.
Right, because I did that, my first block class, where we were doing something not like this, but we were finding the average today, and that's all the X bar is. And I think they had 28, there's like 17 people in there today. I don't even think there's that many, maybe 15. Got like 6 different answers.
No.
And you guys are snickering, but,
Oh, we do the same thing.
oh yeah, there's only 7 of you, and I'd probably get 5 different answers.
7 different answers.
Listen. At least we try, okay?
So to do this,
I don't see my answers this morning.
first thing you gotta do, you gotta find your X bar. If I was gonna write, these are the steps, it's been a while since we've done any steps, I would just write this down out here. That's the first thing you do. The second thing you do is find your S. A lot of times that S is gonna be given to you, or you put your numbers in a list. We're probably not gonna do this. Those are the big long charts that we did back at the start of the year that everybody loves so much. I know you guys wanna go back to, right?
Yeah.
That's what we should
The
do.
what?
Those big long charts at the start of the year,
No.
where we had this column, then we had to fill in that column, that column, that column, that column, so on, so on.
Yeah, alright.
So if we were gonna do this, those charts that we had earlier, we would put them in a list on our calculator. And that might be easier. So instead of sitting there and doing plus this, plus this, plus this, you let the chart do it. Or you let the calculator do it, I mean. So once you find X bar, once you find S, third step, find your critical values, use that standard normal table, or most of the time it's just gonna be that little chart. And sure Mrs. Barnes probably getting upset with me
What?
because I'm tapping on the board so much, my pen's messing up.
That's our thumbs up at the board.
Little chart, that's what that's supposed to say. You guys can figure that out, right? Because I'm tired of trying to write it. Now it's not gonna work at all.
We're done.
Yeah, that'd be fine with me, but you guys probably wouldn't be happy.
We can pick up next class.
Then you find the margin of error.
Yeah, it's debatable.
Use that formula to find the margin of error. That's 3, that's 4.
It's working.
I think it's just that side of the board.
Yeah, I just don't like it over there for some reason.
Yeah.
Over there, right? It's fine.
Once you find your margin of error, do this formula.
Oh, it worked.
Subtract them on the left side, add it on the right side, and just write it out that way.
We have all these fancy new things and they don't work half the time.
Yeah, Mr. Pool's been on me for several years now to let you still have that real old pen.
What's the new one?
I don't know.
He's just
Like the one with the colored ones, like Mr. Bryant has?
No, that's for a different board.
Oh.
He got on me several years ago to switch to that board. Now he wants everybody, now I think he wants everybody to switch back to this board. So the smart boards, everybody was switching to the smart
that's
boards.
smart.
I like the smart boards.
And then
Was there
now I
a ch-
think he wants us to switch back to the other boards.
Was there chalkboards here still, like when you started teaching me,
Yeah,
like?
I put this board up.
Wait, can you come back?
Yeah.
I can't imagine.
Just one second.
It'd be terrible.
I feel like that's all.
Imagine
You gotta
one of
like
them.
erase it, and then you
I
gotta.
still got that.
Remember you?
That's probably been up since you were. Was that here when you were in school?
Was this the front of the
Probably.
room?
Yeah, that was the front of it when I was here. But
You used
there was
to-
a chalkboard here too.
This was that's weird, you're teaching in a classroom you used to sit in.
Couple of this board over here had a graph, like this part of it was a graph board.
So
Like
this is still the math.
Grid on it
room.
for a graph, and then that part down there was a circle graph. It was like the coordinate,
This room has been math
the
room
unit circle.
for years.
It's just a big circle.
So it's like, do they ever change like math and science? Like, have they always been like math and science rooms? Cause like they have like the
Oh.
class lines and stuff too. Like,
Trying to think where, the science rooms have always been those three rooms as far as I can remember.
because of like the class lines and stuff.
Yeah, the math room, Mr. Wendell's room used to be a math room,
He still got chalk.
What year did you graduate?
85.
So you have to-
Construct 95% confidence interval. We have this, we found the E. All you're gonna do to get the left end point, subtract those two, so it'd be 11. And to get the right end point, you're gonna add them. So 13.8, our confidence interval is gonna look like this. Other ways you can write this. You can write it that way. A lot of times in this book, they're just gonna write it like this. They're gonna use a parenthesis, put 11.0, comma, 13.8. And when we get to using the calculator, this is the way the calculator is going to show it to you. All right, so the calculator is going to show it to you this way. We could write it on a number line, show it this way. These are all the different ways we could do it. The fourth way down here, I'd rather you didn't do it this fourth way. It's just 12.4 plus or minus 1.4. That's just being lazy and not wanting to do the addition and subtraction. College admissions director wishes to estimate the mean age of students currently enrolled in a random sample of 20 students. The mean age is 22.9. Notice here, 20 students. From past studies, the standard deviation is known. So they're saying that we know the standard deviation to be that, so they're giving that to you.
So-
One of the times that they could do it.
So like that, since that one's not above 30, we do have to.
We have to know this, then. They have to tell us that. Again, this goes back to the fact, I'm probably not gonna give you a whole lot of problems where you can't do the math, because that sort of defeats the purpose of learning how to do the math. So we look at this, we want 90% confidence interval, they're doing all this. You're gonna look it up on the chart and figure out what these Z-scores are. They're 1.645 and negative 1.645. And we're gonna find our margin of error by plugging in there, plugging into that formula. Again, I would go out more than just one spot. They go out just one. Most of the time I'd go out 2 or 3. This book tells you not to round off till the very end, and then they round off stuff like this right away. I don't understand that. Left end point, we take that number and we subtract it from the X bar. Right end point, we add it to the X bar. We get that, And then our confidence intervals 22.3 to 23.5. So we used, what was that, a 90%? Is that what we used on this one?
Yeah.
90% confident that the mean of the population is gonna fall within that range. And this, you gotta be able to do this. This is gonna be big the next 2 or 3 chapters. With 90% confidence, we can say that the mean age of all students is between, you gotta be able to write it out and explain it, know what you're saying. This is wrong to say there is a 90% probability that the mean is going to be in that interval. That's the wrong way to say it. And I'm going to explain why here in a second as soon as I get to the next slide. When we find these samples, this is our sample and this is our range on each one. Notice what happened here. Did we actually hit the mean of the population?
No, it was on the left side of this.
So sometimes your sample is going to be thrown off for whatever reason. So we're saying in 90% of our samples, the mean is going to fall in that range or in that interval. And here it was 9 out of 10 of them, which would be 90%. On your calculators, you can write this down. On your calculators, go to stat, test, Z interval. So this is something different. We've not been to that before. We went to test before, haven't we?
Like the beginning of the year.
I'm trying to think, what else did we go to? So we go stat, over to test. What did we do? Prop test, didn't we? Prop Z test. Did we do that? No.
No, we haven't done
Thought we went to one of them on test. Maybe not. Prop Z. Be careful because on this Z interval, there's only one Z interval, so that's good. It comes up and it looks, I know this is hard to see, but it looks something like this. All that did. So the very first thing, it says input, it says data or stats. If we're doing data, so right here when we're here, stats is if we know like X bar and the standard deviation and that stuff, and we're just going to put that in. For data is if we put something into the list. Then the calculator will just take the stuff from whatever list we put in there. It'll take the X bar and the standard deviation and stick it all in there. All right, so data if we're putting in a list, stats if we're just punching in those certain numbers. So if we put in stats, then enter, then we put in sigma, which is probably going to be S. Put in our X bar, put in our N, put in our C level. I think on C level, when we go to do that, you got to make sure you put it in as a decimal. So like 0.90 or 0.95 or 0.99. You got to make sure it's a decimal, not the percentage. Then you go down and put it on calculate and you hit enter. And of course mine's going to say error because I didn't put everything in. And then what it'll show you something that looks like this with your left side over here, your right side over there. So if I told you this, let's say we knew X bar, watch closely on this because it's going to be big on the homework. and this is big on the test, I love putting these kind of problems on test. I tell you X bar is 10. You punch all this stuff into your calculator, and it comes out to be 6 and 14 is your confidence interval. Can anybody tell me what E was?
What it meant?
No, what is it for this problem? Remember, how did we get this side? We had our mu that was here. How did we get this side over here?
Subtract
X bar minus E, right?
Oh, well, 10 minus 4.
So E is 4. How did we get this other side?
Yeah, 4.
X bar plus E,
So it was 10.
right? I'm not sure why I told you this. How can we find our X bar if I hadn't told you that?
So if E's 4, you would take 6.
And before we even found that, we don't even need to know that. How can we find what X bar was? What was right in the middle here?
You would
What are you going to do with those two?
add
Add them together and divide by 2. So if I gave you some other range, let's do this. 12, 38. I have no idea. That one I knew what the answer was going to be. First thing I do, find X bar. To find X bar, add these two together,
Over 2.
divide by 2. What do you come up with?
20.
25. Find E. What are we going to do? Once we know this is 25, what can we do to find E? So 25 is right in the middle. All you're trying to do is figure out how far is it from here to,
It's 13
it's
there.
13. So you got to be able to switch those around. If they tell you E, they don't tell you E, they tell you the interval, they tell you X bar, be able to switch them around and do all the different stuff there. So this one we did, and I don't even remember what was 52, 32 divided by 40. I don't remember what it came out to be. It's like 130 or something.
130.8.
130.8. So that's our mean. That's our X bar. We could, if we know all this stuff, we could just punch it into the calculator. You might want to try that right now. Make sure you know how to do it on your calculator. So the first thing I hit, stat, go over to test, go down to Z interval, hit enter, and it says data or stats. We want stats, so you gotta go over to stat and hit enter. Your sigma is 53. Your X bar was 130.8. Your N was 40. And our confidence level this time, we wanted a 99% confidence level, so 0.99. And we go down to calculate.
130.
That's our X bar. What's it give you for?
109.21, comma, 152.39.
So what that's saying, that's that written out that way. What it's saying is, we know that mu, or we're 99% confident that mu falls between 109.21 to 152.39. I like writing it this way because I think that explains more to me than this, but that's the way the calculator does it, so. This is the same thing, just problems that we did. Trying to get through it, too much motion.
Your battery's dying?
Might be now.
Noise. First half.
That's the assignment, page 311, 1 through 28.